Welcome everyone to our 8:30 a.m. session, Fighting Cyber Attacks with AI. We're joined by Sumit Agarwal, co-founder and COO of Shape Security, and Kevin Tu, investor of DFJ Growth. Welcome, Sumit and Kevin. The virtual stage is yours.
Good morning.
Thank you. Good morning, everyone, and thank you for joining us on this first day of the fourth annual MIT AI conference. We're incredibly excited about the speakers and the content we have in store for you. My name is Kevin Tu. I'm one of the conference co-chairs, and it's wonderful to see everything come together virtually after months of planning. As a bit of background on myself, I'm an investor at DFJ Growth, a Silicon Valley-based VC firm that has backed companies like Box, Twitter, Coinbase, SpaceX, Tesla, and many more. I focus my time on enterprise and deep tech investing, AKA all the nerdy and fun stuff. I'm also a MIT CS grad and did research in both CSAIL and the MIT Media Lab. So on to today's conversation, I'll be hosting a fireside chat with Sumit Agarwal, founder of Shape Security, where we'll discuss a variety of topics at the intersection of security and AI. So without further ado, let's kick things off. Sumit, good morning.
Good morning, Kevin. How are you?
Great, thank you. I'm really excited for this conversation that we're about to have, and thank you again for your time. Perhaps just to kick things off, it would be great to get a bit of background on yourself. You've had a wide-ranging career from Silicon Valley Tech to the Department of Defense and the Air Force. Tell us a bit more about the journey that brought you here today.
Sure. My whole career has been about recovering from the original thing that went wrong. I wanted to fly fighter jets when I was a kid, and I had bad eyes. And so I aced all of the Air Force entrance exams. I tried my best to get in, but they just refused to let me go on a pilot track. So I settled for second best, which is I went to MIT, became a course 10, and took on a career in tech. I joined Google in the early days, back in 2003. I spent 7 years there. I was part of a wave of Silicon Valley techies who went to Washington, D.C. in 2009 and 10 to join the Obama administration. And that's where the threads of my career came together. This Air Force background where I was a network warfare officer and the Silicon Valley IT background came together at the Pentagon, where I watched nation states attacking military websites successfully. And the reasons that they were successful were really the seeds of attacks that would sweep the entire globe over the next 10 years. And so in 2011, I quit, finished up government service, and founded Shape to really bring military strategy and the observations that we had made while we were at the Pentagon together into something that would safeguard all major enterprises from the very, very pernicious attacks that we'd observed while I was at the Pentagon.
Awesome. And so maybe as we had in our previous conversation, a great place to start would be, given your experience with Shape Security and now F5, you have a very interesting vantage point on what the bad guys are doing these days. I'd love to hear how modern day hackers are using AI and other cutting edge techniques for cyber attacks. What is going on behind the scenes?
Thanks, Kevin. That's the most fun part. So I'm going to share a couple of quick slides. And you'll all have seen some of these things before, but I want to really double click and show you what goes on underneath some of these things. So on this slide is a CAPTCHA. These are the completely automated tests to tell humans and computers apart. This is the classic thing that most major organizations use to distinguish humans from non-humans. And attackers don't even use artificial intelligence to defeat this. They use something I call average intelligence. So bear with me on this story because it's absolutely fascinating to me how criminals have figured out the world over to completely destroy any form of defense that is meant to face human beings. So you're the defender and you've put this CAPTCHA up in front of your protected asset. And the criminals will do the following. They will host a bunch of video games on the open internet, and teenagers, primarily teenage boys from all over the world, will play these video games. And as they're conducting their attacks, they will, in real time, bring any form of human challenge like that CAPTCHA and insert it into the middle of a video game that this teenage boy is playing, and he will frantically solve that challenge. So they'll have tens of thousands of people playing these video games. That's tens of thousands of ordinary, perfectly capable human beings who are able to solve any challenge that is meant for a normal human being. And so around 5 or 6 years ago, these techniques of combining basic attacks with human beings began to exceed the capabilities of almost every major defensive system that we're aware of. And so CAPTCHAs have really been useless for a very, very long time. So that's one example where the attackers at almost no cost can defeat very, very complex systems without having to resort to complicated technologies like OCR and others that are actually expensive and difficult to manage. Let me give you one more example. This is a work from home sign attached to a telephone pole. Many of you have probably seen these. These are even more complicated and more tempting for people now that they're stuck at home for COVID. This is actually a fraud scheme. If you call the phone number at the bottom because you're an economically or financially distressed person who wants to work from home, you'll be defrauded. And let me tell you what the fraudster is trying to do. The fraudster is going to ask you to perform simple tasks that seem like work, like going to a website and looking up the prices for a variety of products. He'll tell you that you're a product shopper or a secret shopper and so forth. After several rounds of this, the fraudster will say, hey, listen, you've earned $100 and that's great. I want to deposit that money in your bank account, but I can only do that if you go create a brand new Wells Fargo account or a brand new Citibank account, and you just send me the ACH information and I'll deposit the money. And so the fraudster gets you to do this. And then later the fraudster says, hey, there's one more thing. Could you please just send me the username and password? Now, most of you in the audience are probably thinking at this moment, I am way too smart to fall for something like that. I'm not going to give up the username and password to a bank account that I've just created to somebody that is employing me. And that's true, you are too smart. But someone who is financially distressed and who is working from home and responding to this kind of an ad is potentially going to fall for that. And in their defense, the username and password that they're sharing is to an empty bank account. So you send that along and the fraudster at that point has completed the attack. They're now going to use this perfectly well-created bank account that has perfectly legitimate information belonging to a real user to deposit a check that ultimately won't clear and to then transfer those funds to a bank account they control. And so in doing this, the fraudster has completely circumvented all of the defenses that the bank or the credit card company have because a totally legitimate human being with totally legitimate information has signed up for that bank account. And we call that muling, money muling. So those are two examples of ways in which criminals are able to co-opt other human beings to create incredibly simple and yet powerful attacks that I can tell you will circumvent almost any defenses that a well-funded Fortune 500 has put in place. And there are hundreds of attacks like these, and these are the kinds of techniques that create the challenges, Kevin, that large enterprises are facing today.
Definitely, and thanks for the context, Sumit. So you founded Shape Security in 2011 and recently sold the company to F5 for $1 billion. Congrats on that, by the way, big achievement. Can you share a bit then about the platform that you built at Shape and how AI was part of that solution? You just mentioned that there are real humans in the loop that are kind of breaking down these defenses. So what was the use of AI and the platform that you built to defend against this?
So the criminals are co-opting other human beings, and we then have to respond using AI techniques. And Zuli talked about a number of the things that we're going to talk about. As most of you know, the heart of any system that's going to use AI is signals. Let me again pull up my slides here. So we are totally focused on finding unique signals in the context of modern web browsers and mobile applications that no one has thought about using before. You need to find signals that are simple to collect, but subtle from an attacker's point of view. You don't want an attacker to be able to run simple A/B tests and figure out what signals you're using to catch him or her. So let me give you a specific example. This is a notional depiction of a login form. Imagine that a user enters a username and password and clicks on that login button. And imagine that what the attacker is trying to do is penetrate this system by using stolen usernames and passwords and clicking on that button using an automated script, because they want to do that hundreds of thousands or millions of times. So that's one of the key things that we're looking for, is an attacker who is trying to do something at large volume. And so let's look at the pattern of clicks. On the left-hand side, you see the pattern of mouse clicks that come from real human beings clicking on that form. I don't know why they're clicking off to the left and to the right. There's nothing to click on over there, but people apparently click on stuff. And you can see that in the middle where the button is, the red dots, which represent the mouse clicks, are pretty well distributed. They're all over that login button that's a rectangle. Some people have missed, they've clicked above the button, below the button, and look at the distribution of mouse clicks that come from an automated script on the right-hand side. Even though these are coming in low and slow, there's no significant volume, they perfectly fit within the boundaries. And so the ability to create a system that is collecting signals, sending the telemetry and the signals that have been collected to a backend system, analyzing those in real time and saying, I'm going to cluster this group of traffic versus the group of traffic on the left-hand side, that's the platform that Shape has built.
Awesome, definitely. And what a difference you see in the left and right-hand side there. So in our previous conversation, we also spent a bit of time discussing this concept of operationalizing AI. And the fact that successfully selling an AI product isn't just about the underlying models and techniques. And through your process of building Shape and now at F5, what have you learned about the business side of successfully selling AI products and the key criteria for how to really operationalize AI?
So this is kind of the number one thing that we've learned in our 9 years of building Shape as a company. And it's the number one observation that I've made as I look at the way enterprises are applying AI. At the beginning, I talked about the fact that we observed these attacks at the Pentagon. These were nation state level attacks that were attacking military websites. There's a concept from the military that really formed the underpinning of our strategy. And although this concept wasn't created to address AI, I find that it beautifully maps to the reality of how you operationalize AI. So let me again pull up a quick slide here, and I'll tell you a little bit about something that's called the OODA loop. So this is something that a fighter pilot named John Boyd created 30 or 40 years ago to help increase survivability of US fighter pilots against their adversaries. And it's a decision-making closed loop that represents the ability to learn and act more quickly than your attacker. And it has 4 components. Those components are observe. You've got to collect signal data and telemetry. Orient yourself. You've got to have a context within which you apply that signal data. Decide. That is really what everybody thinks about when they talk about AI and ML systems, and they overemphasize that in my observation. And act. You've got to take an action on the basis. If you talk to military officers, they will literally talk about OODA loops as if it's a tool or a weapon that they're using. They'll say, we have to have a better OODA loop than our adversary. We have to have a tighter OODA loop than our adversary or our foe, because if our decision-making loop and our learning loop is tighter and faster and more efficient, then at scale, over many, many iterations, we will very predictably win. So now let's map this to an AI system in the context of cybersecurity. The observation piece we've touched on a little bit. We instrument web browsers with JavaScript. We have a mobile SDK that's collecting everything that a user is doing in the context of an application. Everybody tends to understand that one. The orientation piece is something that Zuli talked about a minute ago. He talked about having the context. Am I looking at human behavior that is going to have certain set of patterns that go this way or that way? Am I looking at a transactional flow over a long period of time that is going to have certain characteristics? So there's an orientation that people tend to underemphasize relative towards to the third component, which is deciding. This is your actual model. This is the specific model that you're looking at. This is the one that's going to say, here is the set of signals that matter. Here's the set of data points that are the ones that emerge out of all of the data points as being anomalous. And ultimately, I'm going to act on those. So I find this OODA loop to be very interesting because it also represents something around trust and control. Are you really going to trust a machine-driven system to act on your behalf? Are you going to allow that to happen at machine speed, which is typically 1/100th of a second, 1/1000th of a second? Or are you going to branch your AI system to always require human review and human intervention? Too often what we see is attackers who are operating at line speed, fractions of 1 second, but defenders who don't quite trust their AI system enough to allow it to act in an automated fashion. And so they'll take that last step around decide and they'll branch that over to a human being. Now, all of a sudden they're operating at minutes and hours or even days while their attacker is operating at seconds. And so these 4 components, if I could leave you with just one thing to go Google up during this presentation or later, and to go learn about how to integrate into your AI system, is the most important thing. If you've got all 4 of these components stitched together in a closed loop, then you've got the beginning of a system that is going to be very powerful. overemphasizing the specific type of model that you use is really where I see most people going wrong. They don't glue this entire loop together into a closed loop, in particular with an emphasis on that last step of acting.
Definitely. And, you know, when you talked to enterprise CISOs and enterprise buyers, how have you kind of used this and applied this to sell the outcome and not just the product? What has that dynamic been when you are kind of in the room making the sale?
So that's actually one of the most fascinating things. The more you focus on AI-driven capabilities, the more you've got to get away from selling inputs and recommendations and scores, and the more you've got to emphasize selling an actual business outcome. We actually came up with a little phrase for what we sell. We sell a clean green graph. So imagine a graph that represents attack traffic that is coming into your environment. It's got all kinds of spikes of angry red traffic when the attacker ramps up the attacks. We don't sell a set of tools or capabilities that the defender is going to use and operate in order to get rid of those attacks. We sell the outcome of that clean green graph. We didn't really realize this back in 2012, but we were happily setting ourselves up really for the right strategic orientation to enable AI-driven services. Because if you're using this powerful AI system to ultimately just come up with recommendations that have to be adjudicated against other recommendations that are going to be looked at by a human being, you're going to get 1/1000th the value that you could out of a true AI-driven system. And so the number one thing that I would tell people who are looking to sell AI-driven systems that are looking to be vendors is, are you selling an input, an ingredient? Are you selling flour and oil and water, or are you selling a 3-star Michelin meal? That's the outcome of actually putting it all together. That's something, again, that we regularly compete with in the market. Lots of other vendors will sell the signals. They'll sell 50 different inputs and a little bit of refined abstraction on top of that. And we focus on selling the outcome. Of course, that's harder. It's a little bit more difficult and it requires a lot more trust on the part of the buyer. But the end result of that is strategically far more valuable because we get real-time data to feed the observation component of our model. We get real-time data to feed the ground truth that drives the weightings within the models. And that has ultimately produced a much more powerful system than almost all of our competitors in our space.
Definitely. Thanks for the context. And so as a part of today's conference, we have a mixture of execs, entrepreneurs, and technologists in attendance. As someone who has built and run a company over the past decade, what advice do you have for AI companies and entrepreneurs building and selling their products in those early days as you're looking for product market fit and then scaling the organization into what it has become today?
I think that understanding the problem that your customers are facing better than they do is vital. And I almost feel on some level as if I cheated because I watched these attacks happen at the Pentagon and just made one bet. If it's happening to the Pentagon, if it's happening to military websites in 2010 and 11, will this end up happening to everybody else in the world over the next 10 years? The answer to that question turned out to be yes. But because we saw it so early, because we saw those attacks being practiced by nation state level adversaries, we got this view and perspective on attacks that was actually far more advanced than the perspective of most of our customers. They didn't know what they were going to face. It was almost a timing issue, which is if you find something out too early, then you're going to struggle also because it just won't be the right time. But we got lucky and it was the right time. And so the big thing for you, if you're going to work in this space and serve customers, is how are you going to gain more insight than anyone around you as a competitor? How are you going to know more about the problem space than the customers do themselves? Imagine if you went to a doctor and the doctor said, hey, Kevin, the quality of the care that you get, the quality of your health outcomes is going to hinge on you reading the physician's desktop reference. It's going to hinge on you reading Wikipedia, and it's going to depend on how well you follow my complex instructions. That'd be terrible. That'd just be terrible. I don't say that. I say, doc, I hurt, make me feel better. That's the correct conversation. But amazingly, that absurd analogy is exactly what every security vendor tells every customer in the Fortune 500 and Global 2000. You've got to send 10 people to training. You've got to read the manual. And if it goes poorly, it isn't because my tool failed. It's because you didn't use my tool correctly. And so the 17 years that I spent in the military were all about understanding that we've got to deliver outcomes to the people who need protection that do not hinge on the quality of skill that they bring to bear on the problem. We're the practitioners that have to have more skill. And so I would encourage you, as you think about this, to build systems that put all of the burden of a successful outcome on your shoulders, on the shoulders of the team that you build, on the engineering excellence that you can bring to bear. Otherwise, what value are you really bringing?
Definitely. I love that advice of understanding the problem better than the enterprise themselves. And so we've been largely focused on your past experiences, but I wanted to take a step back, and if we could look at the broader security landscape, I'm interested in your perspective on what trends and tailwinds you're most excited about. Where will AI have the largest impact, and what will the next generation of security companies look like?
So let me answer that question in the context of society scale security. The thing that I am most excited about is, again, Zuli did such a great job that all the best concepts came up in his, is the idea that the quality of security that Google and Amazon and Facebook and JP Morgan Chase and all of the largest enterprises in the world have can very, very efficiently and effectively be distributed all the way down to the societal level. Like any nonprofit, any school, any business, any corner coffee shop, insofar as it needs very, very sophisticated and high level capabilities. And you may be wondering if the corner coffee shop does, but if they process 100 credit cards a day at the end of 1 year, I assure you they will need very sophisticated cybersecurity, because a small trove of credit cards and of user data and transaction data is now becoming increasingly valuable to attackers who are able to attack at such massive scale. That is the most exciting thing. We're spending too large a fraction of total economic value on security for a mediocre outcome. But when you think about societal security in the real world, at the local level, at the state level, and at the federal level, you have police at the local level, you have FBI for kind of cross-state level, you have DOD, CIA, and so forth at the national level. You've got this whole overlapping set of structures that safeguard every individual, every business, every company, and every kind of entity that exists. And none of them have to be experts at practicing security. But in the online world, unfortunately, the level of security outcome that you get is largely dependent on the level of skill that you have. So we're right now in the middle of building AI systems that are taking everything that we learn from defending the largest enterprises in the world and making that available for 10 to the minus third or 10 to the minus fourth cost, orders and orders of magnitude less expensive than it would have been. And that is really, from a security point of view, in my opinion, the most exciting thing. AI is the mechanism that allows us to distribute these expensive capabilities to the entirety of society very cost effectively.
Awesome. And so we only have 1 or 2 minutes left here. And so I would like to turn to one of the questions that came in from the audience, and it comes from Hardik. Should organizations outsource their AI activities, such as annotations and curation, for regulatory AI model development?
I think that depends on the size and scale of your organization. The largest organizations that I work with generally build in-house capability. Some of the banks that I work with, top 3 banks, have 500 to 1,000 people in one engineering group. And within that group, they'll have data science specialists and they'll have other specialists that are focused on these things because they're going to build strategic core capability. I think if you're not in the Fortune 500, then you should be looking at outsourcing as much of that as possible, because building that OODA loop, which requires a level of context that you inside your organization are more likely to have than the outside vendor, is much more important than the last percentage point of quality in the annotation and the last percentage point of excellence in the model. A 90% model with 90% annotations and 90% everything really, or even 80%, put together in an OODA loop that is properly constructed is far more powerful than one which is spiking to 99% in one module, but doesn't have the other 3.
Definitely. Thank you. And so as we wrap up on time here, Sumit, I just want to thank you on behalf of the MIT AI conference team for your time, for imparting your insights, this concept of the OODA loop, how to operationalize AI. We all have a lot to think about and take back to our respective organizations. So thank you again for your time.
Thank you. Thanks, Kevin. Thanks, Irene.
Thanks, Sumit and Kevin.
Back to you,
really
Irene.
Appreciate your time. Thank you, Kevin. And attendees, thank you also for joining us. We are ending right around 8:55 on the dot, and our next session will begin in 5 minutes at 9 a.m. Please go ahead and join our next session by following the link below this video. All right.